Okay, can you see my screen? Okay, boleh nampak Padlet eh? Yeah, right. Not sure how many students are in right now. But anyway, okay, Assalamualaikum, very good afternoon to all. So, sekejap apa ni eh? Okay, not going to open the video cam, just so that to make sure that the internet line is smooth tonight. So I hope that everybody is ready. Okay, so yesterday we stopped at this point. Means that we did the property of Fourier transform. We did on the scaling, using scaling, shifting, and linearity. Okay, and then I have uploaded to Padlet some tasks that you need to submit in a group. I hope that even though it's a group submission, please make sure that everybody as an individual, please do the exercise. At least when you write out, you need to understand what you are writing. Bukan just simply copy saja daripada your friends. Okay, so because what happened in the midterm is that I think because you simply copy without understanding, and that is what happened lah. Simple signal like signal transformation, time transformation, amplitude transformation is wrong. So concept dah salah, understanding concept. Okay, so before we go to actually the next topic is on this one, convolution and Fourier transform. Okay, so let me just bring that up. So if you have hello, yes, anyone? Siapa cakap tadi? Can you hear me? Can you hear me? Boleh tak? Boleh. I do not see the message or chat. So kalau apa-apa you kena bersuara lah. Kalau tiba-tiba hilang, I memang tak boleh nak nampak lah. Bila share screen ni memang tak nampak apa-apa screen. So I just see my screen saja. Okay, so we will continue with the convolution and Fourier transform. So what you have learned in chapter 2 is convolution. Convolution, tapi you belajar dalam time domain. And for the discrete time, you learn that it's a convolution sum. And for the continuous time, it's called convolution integral. Okay, so the aim is what actually when you do the convolution? Convolution is that when you have two signals, example you have input, okay, you have input over here, okay, and then you have the block diagram HT or response. We call it as the response for the block diagram, so HT. Okay, so sometimes in control, when you learn about control subject, so it's going to be GS lah in terms of S domain. So if it's in the time domain, then we call it as GT. Okay, but it's going to be confusing since I already write here the input is GT. So I'm just going to remove that. So let's say that the block diagram, okay, for this, it's using HT, like what you have learned in chapter 2, convolution. So HT. So we talk about time domain over here. Both are input and output time domain. So what is the output of time domain? So if the signal is convolution, is a continuous time, then you are going to use the convolution integral. Okay, what you have actually answered in the midterm exam lah, convolution integral, whereby you need to do a shifting and so on. You need to inverse the simplest signal, then you do the shifting. Okay, from it's not overlapping until it's overlapping. Okay, and then so why do we need to learn convolution in Fourier transform? So in Fourier transform is that we are going to do it in the frequency domain. So whatever t, we are going to convert it into frequency domain. So you have learned using table, Fourier transform table to convert from time domain to frequency domain. So where's the table? Table yang ni lah. Okay, from time domain to frequency domain. So if you have an exponential signal in time domain, then you directly use the table. No need to derive it using the general equation. Terus gunakan Fourier transform table. Right? So that's the beauty of using Fourier transform lah sebenarnya. So when you have it in terms of a frequency domain, then it's going to be easy to actually get the answer. So y in frequency domain, omega is equal to g omega times h omega. So it's just a multiplication of the value. So after you get the answer, y omega in frequency domain, then you normally the question will ask you, okay, find. So using Fourier transform, example, you are given the equation in time domain gt and ht. Okay, so find the yt in time domain. So dia suruh dapatkan yt in time domain, but using Fourier transform. So keyword dia using Fourier transform lah. So when using Fourier transform, okay, is it I'm offline? I offline kejap tadi ke? Tadi I hilang ke? I hilang Okay. Okay, internet lah ni. Okay, so huh? Sekejap, dia bad connection. Sekejap Poor network. Allah, malam-malam ni poor network pula. Poor network quality. Yeah. Okay. Uh, can you hear me? I just changed the internet right now. Boleh dengar Okay. Sorry about that. Okay. Alright. So saya sambung balik. Sorry, internet Unify ni malam-malam tak kuat pula. I kena guna data Hopefully data ni okay. Okay, so we continue with this. So what we have here is that so the question was that to find the output in time domain using Fourier transform. Tak nampak? Ada tak? Saya dah share. Alert. Saya tengah share slide. Ada tak? Nampak slide tak? Slide ke Padlet? Siapa yang nampak slide, boleh tak bersuara sikit? Nampak slide Okay. Alright. Slide Okay. Okay, so find the YT output using Fourier transform. So after you get the y omega in frequency domain, then you need to convert it into yt in time domain lah. So how you use it is that you are using the inverse Fourier transform. Okay, inverse Fourier transform. Okay, so in this convolution, you are going to use both lah. You are going to learn how to do the convolution using Fourier transform and then inverse it back to the time domain. So just a recap on what you have learned in convolution integral last time is that it's in time domain. Xt input, ht is the system or impulse response. So find yt in time domain. So in the convolution, in the Fourier transform, you are going to use, you are going to convert everything in time domain to frequency domain, do the calculation, and then going to reverse it back to time domain. Okay, so this is how you're going to do it. So time domain to into frequency domain will be called as Fourier transform, and then you inverse it back will be inverse Fourier transform. Okay, so let's look at an example directly. So using a convolution property, okay, to find the Fourier transform of the system output y omega. So you have here y omega. Okay, so find y omega. So the question is that find y omega for the following input and system impulse response. So you are given xt. So let's say that we just ignore this. Okay, so let's just copy that. Okay. So let's say that without looking at this one, don't look at this. Okay, just read the sentence. So find y omega if you are given the following input, okay, and system impulse response is given by xt and ht. So just draw out the block diagram. Okay, so normally in the final exam they don't give you this block. Okay, they give you the question only. So you have input xt, you have ht. Question is that find y omega. So whereby before you can find y omega, of course, if you are given this in time domain, then what you have here, the output will be in time domain lah, yt. Then what you need to do is that, okay, since it asks you to use Fourier transform, so each of this component, okay, you need to convert it into frequency response. So you're going to convert it to x omega. This one is converted to h omega, and therefore you can get answer y omega equivalent to x omega times h omega. Okay, so let's do one by one. So the solution is, okay, please you guys over there, wait a while. Okay, let's do one by one. We take the input xt. Okay, xt equivalent to 3e minus t ut. Okay, so by looking at the Fourier transform table, so refer to Fourier transform table. So refer to Fourier transform table. What you want to refer is in the exponential value. So open up the Fourier transform table. So you have, just now you have exponential, right? So exponential, let's take out that equation. Okay. So by having this, you will see that what is the value of UA over here. So you need to find what is A. So A equivalent to, what is the value for A? Guys? Cuba compare kan. 3, you have 3E minus T kan. UT. So what is A? A equivalent to 1 Okay. So A is 1 Okay. So therefore you may write X omega equal to what? Okay. Write out this equation lah. 1 over, what is it? 1 plus J omega. Okay. So as simple as that lah, to get the X omega. So that one will be the first thing that you need to do. Okay. What else that you need to find in order for you to calculate for Y omega? So you have actually get what is X omega over here. So now you need to find what is H omega. Okay. So H omega so you have HT is equivalent to 2 E minus T UT. Okay, let's check betul tak? Betul. 2 minus T or minus U 2T minus minus 2T. Right? So, for this case, what is the value of, any, betul ke ni? Is it correct? Kita tinggal value trigger So let's just write that out. 3 1 over 1 plus J omega So we get 3 over 1 plus J omega. Okay. Another one is that you have 2. Okay, we take out because we want to leave it in terms of E. Exponential ni E minus T. Okay. So we take out that value. Okay, so what do you have here? What is A for HT? A equal to 2 So you have 1 over 2 plus J omega. So you have 2 plus J omega. Okay, so now you can actually write out the equation Y omega equal to X omega times H omega. Okay. Get smaller. Okay, so H omega equivalent to X omega times, this one is H Jangan lupa write it out. H omega. So what is it? X omega? 3 times 1 plus J omega multiply by 2 plus J omega. Okay. So multiply that, the upper value. So 6 1 plus J omega plus, times 2 plus J omega. So what we need to do here is that we are going to use partial fraction. Okay, so we are going to divide it A plus 1 plus J omega plus B over 2 plus J omega. Okay, ingat tak partial fraction? Okay, this is mathematics So you need to remember how to do partial fraction. Okay, so how do you get A value here using partial fraction? Ingat tak? Anyone? Okay, using partial fraction A equivalent to what? Ambil value yang atas ni, 6 ni. 6 over, so take the side here, 2 plus J omega. Whereby J omega equal to this one lah. Ambil yang belah bawah dia ni. So, the underside of A plus J omega. So, if I write out here on the right side, A plus 1 plus J omega. So, you take out this part. 1 plus J omega equal to 0. J omega equal to minus 1. Okay. So, that's why you have J omega equal to minus 1. Okay. So, what do you get? Cepat. Cuba calculate. Dia dapat apa? Okay. 6 per 2. Gantikan lah tolak 1 So, betul tak? Tolak 1 kan? So, you dapat 6 A sama 6. Okay. So, B sama juga. Cara yang sama. So, B apa? B equivalent to, ambil 6 ni. 6 over, what is it? Cross, ambil yang cross So, ambil yang 1 over J omega. Okay. Maksudnya, ambil yang cross belah bawah ni lah. Okay. And then, what is J omega? J omega equivalent to minus 2. So, what do you get? 6, 1 tolak 2. Minus 6 Okay? Ada yang tak faham part yang ni? Tak faham? Better tanya sekarang. Sebelum kita teruskan kepada lagi complicated. Ada yang tak faham? Okay? Kalau faham, then saya teruskan. So, kita sambung kat sini. So, since we already find out what is A. Ni A kan? A tadi, A equal to 6. And then we have B pun kita dah jumpa. B equal to minus 6. Okay. So, just substitute lah value tadi. So, A adalah 86 over 1 plus J omega minus 6. Okay. 2 plus J omega. So, you already find out the answer. Sebenarnya, okay, ini adalah jawapan untuk H omega. Okay, so what was the question? Use convolution property to find the Fourier transform of the system Y omega for the following input and system input. So, this will be the final answer. Let's see. The question is, okay, instead of find H omega, Y omega, sorry. So, they want you to find YT. Okay, so YT. Are you going to use the convolution integral to answer this? No, tak payahlah. Okay, you're still going to use the inverse Fourier transform. Okay, so you're going to find what is HT. How do you find inverse Fourier transform? Okay, by looking at the table. Table tadi. Mana table tadi? Yang ni kan? Okay, ni table dia. Okay. So right now, what you have here is, you have in terms of dia kan, X omega kan, in frequency domain. So you are going to inverse it back. So you are going to use inverse Fourier transform. Okay. So you have the in this form kan, 1 over A plus J omega. Right. So just take out, since this in this equation is left with 1 so we take out 6. Okay. Let's say I take out 6, 1 over 1 plus J omega minus 1 over 2 plus J omega. So, is it more clearer? It's going to look like this table. Okay, Okay, so you have 6 in bracket. Okay, in bracket. So what is the A value? A is 1 kan? So just write out lah. E minus T ut minus, for this case is that A is 2, E minus 2T U E. Use square bracket So this will be the answer for HT. Okay, so now you have learned how to use convolution using Fourier transform and using inverse Fourier transform. Yeah. So this one is a simple example lah. Okay, simple example. Any question from student? Any part in this one that you don't understand? Y omega. Y omega. Oh, Y sorry. Betul. Okay, Y output Thank you. Sebab D takkan ada 2 kan. So this is Y omega. H omega. This one is H omega. This is HT. This is HT. Okay? So ini betul tak? Yang ni XT betul. H input input dengan respond betul. So kenapa I salah lagi? Y kan? Y. 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 Okay? Right, thank you for that. Okay, next question Okay, no question. Let's look at another example. So in the other slide, another slide is that this one is just the steps lah, the same step that I explained just now. Let's look at this one. Okay, so you have a system characterization using linear differential equation. So if you see here is that summation of AK dyt per dt equal to summation of bk dx d per dt. Okay. So same thing. So if you have it in terms of the frequency domain, then you can use the inverse Fourier transform to actually inverse it back to the time domain. So let's look at this example whereby you have a signal in terms of differential equation. So it asks you find the system response in the frequency domain. Okay, so find it in terms of HT and XT. So basically what you can see here is that you have the Y output term in differential equation and you have the input So basically it's like this lah. You have the input XT, you have the output YT. So they ask you to find what is HT and also in J omega or H omega lah. Okay. So in order for you to answer this question, so since it's given in differential equation, so we are going to directly look at the Fourier transform table. Okay, so go down. Okay, this one. If you see this one, differential in time. So by referring to a table, so the solution is that, okay, the solution, okay, by referring to Fourier transform table, which is this one, okay, so we are going to compare, okay, compare it directly. So it's given by, this one is in time domain, this is in frequency domain lah, j omega or omega, okay. So you are given by d over dt xt. Okay, for this case is that dy per dt lah. So it's the same thing lah. So let's say that if I rewrite again the equation, if I rewrite here since you have here is dyt kan, dyt per dt. So what is the frequency domain in the frequency response? So you have j omega y j omega. Okay, so we write this. Okay, so you have dyt per dt plus yt equivalent to xt. Okay, so for dyt per dt is this one. So you directly write it out using by referring to Fourier transform table. You have j omega, just compare it directly with the Fourier transform table. Y omega plus a y omega equal to x j omega. Okay, so you group it together. Y j omega is a plus j omega equivalent to x j omega. So from this plot diagram, okay, y omega or j omega, I am sebenarnya selalu tulis omega saja, too long. So x j omega equivalent to what is it? Is x omega times h omega. Okay, so your question is that to find what is h omega, right? Which is this one. Wait. No, so the question is that to find h omega. So h omega equivalent to what? Y omega over x omega. Okay, so you need to compare it with this one. Okay, you want to find what is h omega kan? So h omega is y omega. You have y omega over here. You have x omega over here. Okay, so rearrange it, y over j omega over x over j omega, you get what? 1 over a plus j omega. Okay, move it to the back, to the right side macam ni lah, cross So this will be equivalent to h j omega. Okay, so you get it in terms of the frequency h in frequency domain. So how do you get it in time domain? So ht referring to Fourier transform table. Okay, refer to Fourier transform table. So what do you get? Fourier transform table, e minus t u t. Okay, your A is 1 lah. Okay, A is 1. So, A Okay, A is what? A is minus 4. You need to write it there lah. Okay, A plus J omega. So, which is you use this table again this one. Okay, this one So you have 1 plus AJ omega. It's the same, right? So that's why your answer is A minus D 3 E minus AT UT. Of course, if you have a value for A, then you need to put that value lah into the equation. Okay, so any question on that? Sample example? No? Okay, if no, then let's proceed to another example. Okay, this one. This one. Mana? This one. Okay. So okay, done So how do you get this HT is that's why always draw out the block diagram this block diagram. Draw it out. Okay, so that when you draw it out then you are more clearer how to Kenapa I dengar suara I bergema? Okay, so you need to write it out, draw the block diagram, then you know when you write out the equation y output equal to input x omega times h omega, then you can actually calculate what is h omega because you need to rearrange again over here, down here. Once you already convert it into Fourier transform using to frequency domain using Fourier transform, then you need to rearrange the equation in terms of hg omega lah. So from here you can directly use the table to get it the answer in time domain. Okay, so this is an easy example lah, senang je. Okay, let's look at a bit difficult example whereby you have value on both sides. So you have both sides. You can see that you have on the left side is yt and differential equation up to second order. Okay, you ada d squared d squared dyt squared over dt. And then on the right side you have also xt in terms of differential equation. Okay, so using the same method, let's see how you answer this. So far okay tak ada disconnected I lah maksudnya I tak ada okay. So let's take out the equation again, Fourier. So remember in the exam you are given this table so you need to know where to find it lah. Okay, for the mana tadi differential equation in time domain is over here. Okay, so solution. Write out first the equation d squared dy over t plus 4 dy d over dt plus 3yt equivalent to dxt over dt plus 2xt. Okay, so if you look at this, it's very direct lah. So you have d over dt is over here, but you look at this part is that you have the to the power of 2 kan. So basically for dx squared per dt is actually you have d omega squared x d omega lah. Okay, so when we use refer to Fourier transform table, so refer to Fourier transform so you can rewrite this as j omega squared okay plus habis lagi you have y omega plus 4 y omega plus 3 equivalent to, so you have the s per dt over here, so the s per dt is this one, so j omega x omega plus 2x omega. So you just group it together, y omega j omega squared plus 4j omega plus 3 equivalent to x omega j omega plus 2. Okay. And as usual, since we need to put it in terms of equation, okay, so you have here input x omega, output y omega, so you have h omega. Okay, so what we want to find is we want to find what is h omega. So if you want to rewrite, you don't need to actually memorize it. So y omega is x omega times h omega kan. Therefore h omega equal to y omega divided by x omega. So by having that, so rewrite again this equation in terms of y over, so we have y omega over x omega. This one is equivalent to h omega. So you need to actually bring this power, okay, cross it lah. So you have 2 plus j omega over j omega squared plus 4j omega plus 3. So so how we are going to solve this equation? So we are going to use the we divide it into, okay, j omega. So how are you going to find the value here? J omega. Using calculator, You know how to find it? Guys? No. Dalam matematik kan ada belajar. You dapat apa? Plus 3 dengan plus 1 Okay. Siapa yang tak tahu tu kena belajar lah. I tak boleh nak tunjuk sekarang ni Okay. Sebab ni guna calculator saja. Simple je. You should have learned it. Because dalam control pun ada belajar juga Kalau you tak belajar then mungkin you terlelap lah dalam subjek control. So go and find out how to find that. Okay. You can use calculator or you just simply add it up again. So now you are in this equation. So as what you have done in the previous equation, so you dapatkanlah j omega plus 3 plus b over j omega plus 1. Yang ni tadi siapa yang tak dapat jawab dan kena pergi carilah macam mana nak jawab, pergi tengok YouTube ke apa-apa lah Okay, kena you guys dah adult, you can actually find out or ask anybody in your class that know how to answer this maths. Okay, I mean just applying maths inside this subject So right now you have in this equation, so you can proceed to get the partial fraction. So using partial fraction, so A, we have 2 plus j omega. Okay, cross that over here. So you have j omega plus 1, whereby j omega equal to minus 3. So what do you get, A? Berapa, A? Anyone? One over 2 Okay, good. 1 over 2. So next, B. Using the same method, so B, we take out the value 2 plus j omega over cross that j omega plus 3. J omega equal to B is minus 1. So what do you get? Same, Okay. So now, almost finished. So, gantikan je. So, we have 1 over 2. Okay. 1 over j omega plus 3 plus B, we have 1 over 2. 1 over j omega plus 1. The question also asks you to find, so this is the answer in frequency domain. Okay, so the question asks you to find in time domain. Okay, time domain. So using inverse Fourier transform, which is using this equation, wait, mana? So by looking at this, okay, compare it. So you can write it out 1 over 2. For this case, A is 3. So E minus 3E ut plus 1 over 2. A is, so this is A, this is A. So your A value is 1. So E minus T U B. So this will be the answer in time domain. Okay. So that will be exercise number 4. Okay. Yeah, I'm going to ask you guys to do exercise number 5. Do it in a group. Okay, so we have until 10 p.m. So in a group, okay, consider the example in example 4 just now, this one. So what you get is in H omega. Okay, so suppose that the input, so consider the system, means that the system, what does it mean by system is that H omega lah. Okay, or H P. Okay, so given by, if you're given yt, find the output. Okay, yt and y omega. So meaning that right now you are given H omega, you are given xt over here, xt. Okay, so I'm going to write this in time domain. So we have ht. So they ask you to find what is yt and y omega. Okay, so do this example. Okay. So I will just start it off so that you can continue. Okay, so the solution. For the case of this, of course, you want to answer it using Fourier transform lah, since we are in Fourier transform chapter. So first, you have your equation yt, but it's in time domain kan. So what you need to do is that you need to convert it to frequency domain. Okay, x omega. Okay, so xt is given by e minus t ut. So get what is x omega. So what is x omega? By referring to the Fourier transform table, yang ni lah. Okay, so Fourier transform table, your x omega is 1 over your A is 1 kan? So 1 over J omega. Okay. So you already have xt, x omega. So ht is given in the previous question. So h omega is from the previous answer. So h omega, just write it out again. So h omega is j omega plus 2 j omega plus 3 times j omega plus 1 kan. So this one was from example. Example 4. Okay. So the question is that find yt. Y omega. Y t. So y omega equal to what? X omega times h omega. Okay, so gantikan je lah yang ni, value ni. Ni kan? Ni dengan ni. Okay, so you have 1 over j omega plus 1 times j omega plus 2, j omega plus 3, j omega plus 1. Okay, and you see that this one is actually is the same, eh? So if I write it out again, j omega plus 2 is j omega plus 1 squared j omega plus 3. So how do you find the partial fraction for this? So partial fraction is that you have a over j omega plus 1 plus b over j omega plus 1 squared plus c over j omega plus 3. Okay, this is a bit tricky about finding the partial fraction value for the a, b and c. For b and c should be no problem. B and c is the same method. This because you have another numerator over underneath here. So for the case of b, it will be straightforward lah. B, you will write it as j omega 2 over, okay, look at this side, what do you have? So j omega plus 3, which is j omega equal to minus 1. So find that value. C, you have j omega plus 2 divide by, wait, divide by j omega plus 1 squared j omega equal to minus 3. So get the answer. For the case of A, it's a bit tricky since this one you have another numerator over here, j omega squared. Ada lagi satu over j omega. Okay. So how do you find it? For the case of A, you need to use the different equation for using the concept of differential equation for two function. So if you remember, I'm not sure if you remember last time, if you have u x equal to u over v, okay, so what do you have dx over dt? How do you find this? Okay, so you can find it using the equation, okay, v du over u dv over v squared. This is the equation, maths equation lah, to solve for differential equation. So when we look at this a value, okay, we are going to solve it using the same concept. So you have here j omega plus 2 over j omega plus 3 eh. So this one is your u over v lah. Okay. So what you want to find is that you want to find A, which is d over d j omega lah. So using the same concept as this one, so you are going to just use this equation. Okay, so what is V? V j omega plus 3. Okay, differentiate u. Since this is differentiate j omega, so you get 1. And minus u dv. U, what is u? Jv j omega, j omega plus 2. dv is underneath here, so differentiate j omega, so you get 1 over v squared j omega plus 3 squared. Okay, and this one for j omega equivalent to minus 1 So just substitute the value, so minus 1 plus 3 minus 1 plus 2 minus 1 plus 3 squared. So if you did calculate this one, you will get B value is 1 over 2. C, you will get minus 1 over 4. And A, you will get 1 over 4. Okay, so from this step is that you need to use this concept lah, using the dx over dt. So v du v u dv over v squared. Okay, so then you can just substitute the value that you find for A, B, and C. So y omega equivalent to, okay, just write it again, A j omega plus 1 plus B over j omega plus 1 squared plus C over j omega plus 3 plus 3 ke? Plus 3. So substitute the value for A just now was 1 over 4. 1 over 4. Okay, 1 over j omega plus 1 plus 1 over 2. B is 1 over 2. 1 over j omega plus 1 squared plus C is minus C is minus 1 over 4. 1 over j squared plus 3. So this is the answer for y omega. Okay. So how do you find for yt? So by referring to the Fourier transform table, Fourier transform table. Okay, for Fourier transform table, this two is direct, tak ada masalah yang ni. Okay, so if you write here, what you get 1 over 4 E A is minus 1 T T plus this one is, you need to be careful, you have 2 power of 2 2 power of 2, so you need to refer to the Fourier transform table. You have power of 2, it's over here Okay, this equation. Okay, this equation is for the second one. So you have the power of 2. So this one, the power of 2. So you have 1 over 2 t e a is minus 1 t u t minus 1 over 4. This one is the normal equation, minus 3t u t. Okay, so this will be the final answer for YT. Any question? Except for how to get the numerator just now. So that one do open back subject control. Subject control or subject mathematics. You should have learned that how to find the value for the numerator. Okay, so any question? No? If no question, hello? Hello? Okay, no question. So if no question, then we finished here. But before we go this Thursday, okay, what I want you to do first is that for this Thursday it will be a bit much more complicated. So if you see in signal system, it's not about only the signal itself. You need to understand. It's about the mathematics. The basic mathematics, fundamental of mathematics, you need to be strong. Kalau you ada how to do differential equation, you do not understand, then you need to open back the subject, mathematics subject, buku, buka balik buku, nota yang dulu-dulu, buka balik. Okay, and second one is that, if you see here, example that we are going to do on this Thursday, we are going to do circuit analysis using Fourier transform. So what I want you to do before this Thursday class is that go back and open circuit 1. I think you guys already taken circuit 1, or are you taking this semester circuit 1? Guys, are you taking circuit 1 this semester already? Anyone taking circuit 2, but I'm sure this is cover only circuit 1, and this one simple question, circuit equation. So we are going to apply circuit application lah. So this is example of circuit we are going to apply using Fourier transform. So just go through the slides that I have here, revision of circuit theory and control 1. So if you're taking control 1, then it should be almost similar. But please focus on the impedance. So we are mostly using on the impedance Z value. Okay, but you can go through what is the voltage current in terms of the equation and so on. Okay, and go through all of this. This is just a recap or revision on circuit theory. So go through until slide. Okay, this is on parallel resistance, summing circuit. Go through, and this is just example on how to do calculation for output. Read through until this one. Okay, this slide. Transfer function of multiple loop. For example, if you have multiple loop, how do you get the equation? Okay, ni you need to open subject control 1. You have learned this in control 1. I think this semester good. Okay, so I will, and on Thursday I will directly go to this example. You're going to go to example 9, how to answer this. Okay, and then also exercise 6. Exercise 6, yeah, maybe, or you're going to submit it in Padlet. And there are a few example of past year exam, final exam using application. So you have a circuit whereby you have resistance and you have a capacitance. Example, you have also capacitance over here. Okay, so on this Thursday we are going to finish chapter 4, and as I mentioned in class, we are not going to cover for discrete time Fourier transform, since in final exam we only cover in until continuous time. But anyway, you can go through the discrete time notes. It's almost similar how you do the calculation. So if you want to go through, it's the same thing. You still have the convolution for discrete time, same thing. Just refer to the table and get the answer. Okay, but I'm not going to go through this for discrete time. So we are going to complete chapter 4 up until the circuit exercises on the application of circuit analysis. Okay, so I think that will be all. Sekejap, macam mana nak? Okay, stop presenting. Okay, I think that will be all for today. Okay, so for those who didn't understand how to get the equation for the numerator equation just now, then you need to learn how to use, you can use calculator actually, but I cannot show you here. You can use the calculator under mode. If you press on the mode, you will find an equation whereby you click until you get a degree there, DEG, degree. Okay, you click on that degree. Okay, and then for example for the skate just now, degree is 2 degree kan, so you put that 2 degree and insert the value. Okay, so if you have a calculator, you should have the manual of the calculator. Okay, manual of calculator. Do you have the manual of calculator? If you don't have, then download the manual online lah. I think zaman sekarang dah ada dah manual di online. Last time we don't have that manual online. Kena ada manual lah when you buy the calculator. So download the manual of your calculator. Try to find out how to find that partial fraction value for a value. Okay, just now. Okay, so I think that'll be all from me. Okay. So see you guys on Thursday at 8:30 a.m. Okay, that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.